In the same vein of trying to clarify the language we use, I have a series of explanations for what the various arrows we use look like. So I was just describing what the reaction arrow setup always is, which is to say you have a reaction arrow, you have reagents, solvents, temperature, and time is part of explaining, hey, this is how we do synthetic steps in the forward direction. So in a synthesis sense, you use reaction arrows, and that really explains what's going on. If you are designing a synthesis, then you need retrosynthesis arrows, which is to say this one thing came from this other thing. So this product came from this starting material is how you use a retrosynthesis arrow. But we also have other arrows that we use throughout, and these tend to show up more in mechanism type problems. And you are already familiar with the electron flow arrows, the curved arrows. And again, what these mean is electrons start somewhere and they go somewhere, and they can actually be two-headed, two-electron arrows, so a double-headed two-electron arrow, or later in the course we're going to use single-headed arrows if we're talking about the movement of a single electron. And we also have resonance structures type arrows. So if you're trying to indicate that two things are resonance structures, what you do is you use these sorts of double-headed arrows like that, and then you enclose both resonance structures in brackets. So this is the way you notate, hey, these are resonance structures. When you are doing those mechanistic steps, almost always, you're trying to describe an overall reaction, but each step is either related by equilibrium or perhaps an exaggerated equilibrium, where equilibrium lies mostly to one side or perhaps the other. And then you have arrows that are simply one way. So equilibrium is any sort of acid-base type step. It could either go in either direction, but sometimes you will say, hey, this is really something that's largely one directional or entirely one directional, and you can use these arrows as well. So anyway, this is part of the symbolic language of organic chemistry. If you understand this stuff and you can use the electron flow arrows and resonance structures well, then you're a huge part of the way. I invite you to start getting better at the retrosynthesis arrows and using them as you figure out your synthetic operations. And as you're drawing out those mechanisms, you really need to be paying attention to whether these are equilibrium steps or steps that go in only one direction.